Okay, now let's calculate the time that it would take for the swimmer to go on the other side. The time it would take, as we have seen a moment back, would be the displacement upon velocity along y-axis. That is the time it would take to go on the other side, because the velocity along the x component, or the velocity along the river, is just going to take the body or the swimmer along the river. To go on the other side, the velocity has to be only the component of velocity which is perpendicular to the river, that is only would be responsible for taking the swimmer on the other side. So the time taken for the swimmer to go on the other side would be distance that it has to cover, assuming that the width of the river is d, upon the velocity along that width, that would be Vm cos theta. Vm sin theta and Vr are perpendicular to this displacement. Vm cos theta is going to help. So d upon Vm cos theta. This is the time that it would take for the swimmer to go on the other side. Okay, now drift. While going on the other side, the swimmer is not going to land just at the point exactly opposite to the starting point. He's going to go somewhere here. So there will be some drift. The distance between the final position and the initial intended position, or the point just opposite on the other side, this distance, that is the drift. The drift will be equal to the velocity, and the velocity component which is along the flow of the river, that is responsible for causing the drift. And this Vr minus Vm sin theta, this is the component along the flow. This velocity is going to cause the drift. So drift will be Vr minus Vm sin theta. This is the velocity component that is going to cause the drift. Velocity into time, that is going to be the net displacement along the flow of river, and time taken for the journey is d upon Vm cos theta. This is a general analysis, and this is the maximum 4 things that could be asked in this kind of problem. So for any given angle, this is what we have to do. This is pretty simple. Now what you have to do is, on a piece of paper, you have to derive all these 4 things 2-3 times. For the first time you will learn, for the second time and third time you will generate speed, which is as important as learning it for the first time. Okay, so this is the analysis of this. Now I'm rubbing this one off. Now the final thing that I would ask you here would be, how should the swimmer go about swimming in order to keep the drift minimum possible? This is the drift that we have calculated. We have seen how the swimmer should go to cover minimum distance during the travel. We have seen how the swimmer should go in order to minimize the time of travel. Now we are going to see how the swimmer should go about swimming in order to keep the drift minimum possible. This is the expression of the drift, and as we can see, if we are keeping Vr and Vm constant, suppose we are keeping Vr and Vm constant, then how should the swimmer go about swimming to keep the drift constant? So now the variable would only be theta to keep the drift minimum. If Vr and Vm are constant, now how should the swimmer go about swimming to keep the drift, or to make the drift minimum? Now then the only and the width of the river, that is also constant, Vm is constant, Vr is constant. So the variable here is theta. So drift is a function of theta, and we have to minimize drift when theta is variable. Now in this kind of thing, you know what you have to do. Actually you have to differentiate the function with respect to theta, and then you have to find at what theta will the drift be minimum or maximum. That's what you do. That's what we have learned in the differential calculus that we have studied before, and for this day we studied that. So what you have to do is, you have to differentiate drift with respect to theta, make that 0. When this happens, at that point, for theta which will satisfy this condition, at that theta the drift will be minimum. Okay, because we have seen at minimum and maximum the differentiation of the function with respect to the variable is equal to 0. Okay.